Vertex form of a quadratic function. The height of a thrown ball is quadratic function of the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 120, and the path of the ball includes points 0 and 4. What is an expression that defines the function? Write the quadratic equation in the vertex form. So here, first of all, let's take a pen here, and let's try to do the work. So now what is important here to find out is the vertex, which is 1 and 20. So I'm taking the vertex 120, and the other information that we have to take from the text is the point 0 and 4. Even if we look in the figure, we already see this information we have in the figure here, 0 and 4. So 0 and 4 is a y-intercept of the function. And now the quadratic formula in vertex form is y is equal with a parenthesis x minus h, everything is in square, plus k. So now we already know those elements here, what we have. This is a h, this is a k, and this is a 4, was right, 4. This is a x, coordinate x of the point, and a y coordinate of the point. This is a y. And now let's go here, let's solve everything. And y is equal, so I'm doing one extra step here. A in x, instead of the h, I'm plugging the value of the vertex here, h, which is 1 minus 1 square, and is a plus 20. Instead of the k, I'm putting 20. So I created a quadratic equation for the specific case. For this specific case, what we have here. But a, we don't know what is the vertical stretch or compression. This factor a, we don't know. But in order to find the a, we are taking the x coordinate and y coordinate of the point, which is 0 and 4. And now instead of the y, I'm plugging here in 4. And instead of the a, I'm leaving a, because we don't know what it is, we are trying to find a. And instead of the x here, I'm plugging here, instead of the x, I'm plugging 0. 0 minus 1. And everything here is in square, plus 20. And now let's simplify a little bit this equation. And this equation here is equation with one unknown, so is easy to solve it. We solve like a linear equation with one unknown. So 0 minus 1 is minus 1, and square is 1. 1 times a is just a. So we don't have to worry about it anymore. Plus 20 on this side. And now we are subtracting both sides by minus 20. This side and the other side, both sides. Equality of property in addition we using. We add the negative 20 both sides. So this goes away, and 4 minus 20 is minus 16. So this is minus 16. So a is equal with minus 16. And now we can a is minus 16. The factor a here is minus 16. Now we can write this equation, a quadratic equation for this specific case. What we have here, we can write y is equal with instead of the a, minus 16. So we have all the numerical values for all the variables. 16, which is x minus 1. This is a square, plus 20. This is the formula, and here we are done. But because this case is for the height and here in the y-axis represent height that depends from the time, in terms of the time. And if we are looking here for the vertex, it says when for 1 second the ball, the height of the ball was 20 feet high. So it was 20 feet high. And now if we are looking now to write here in with the actual terms, we would write this function h of t. We can write this h of t is equal with the minus 16, and instead of the variable x and y we just replace in h of t, function h of t, and the t, and here is a t minus 1 square plus 20 if we want to write more professionally and in a fancy way, we can use this equation here, h of t. But when we are finished in this equation with the red, what I wrote here, y is equal to minus 16 x minus 1 square plus 20, it satisfies the equation. And here is the answer here, minus 16 x minus 1 square plus 20. So this is the answer.